value? 1. Do you notice how they're different numbers?
Yes.
That's not allowed. That's when a limit doesn't exist. So letter A is talking about that you are approaching a different number from the right-hand side than you are from the left-hand side. So letter A is talking about condition 1. I approached two different numbers. From the left here, I was approaching -1. From the right, I was approaching the y value of +1. Since those numbers are different, the limit does not exist as you approach 1. You would write it d n e. Does not exist. In part B, if I graph that function, we've had a lot of experience with that function, the 1 over x inverse variation function. If I graph that one, it looks like this. In the orange. Notice that I am approaching 0 on the x-axis. That's what they care about. So as I approach 0 on the x-axis, from the left-hand side, I trace my function, and as my x values get closer and closer to 0, my y value is going to
Go decrease. Plunge. To the floor. To the ground. Go hell.
Good job, Carly. Can you say that again, please? Negative infinity.
Oh.
Not O. Negative infinity. As I approach from the right-hand side, and my x values get closer and closer to 0, my y value approaches
Positive infinity.
positive infinity. Joe didn't even know what he was saying, and he said it out loud anyways. Good job, Joe. Letter B is talking about you increase or decrease without bound. The phrase without bound is talking about going to some kind of infinity. Plus or minus, doesn't matter. What should I write down as my limit for letter B? Does not exist.
D&E.
So let's look at the third example. Just watch mine, don't bother doing it yourself.
What? You probably couldn't do it anyway.
What number am I approaching?
0.
Okay, thank you. So I go to my table set, type in a 0. I'm going to make sure that I'm in the correct mode, so I'm going to go with radians, because generally speaking, you're in radians. Let's look at the graph. Oh, kind of looks like a W, doesn't it?
Yes.
I can't really tell what's happening close to x value of 0. So I'm going to zoom my graph in just a little bit.
Just a little bit.
Or sometimes people like to say, wiggle it.
Rigor. Wiggle it?
Just a little bit.
Wriggle.
Okay, we look at the graph again. Pay attention. Whoa!
Oh, would you look at that?
That is way too weird.
Let's get a little closer,
Oh,
just in
would
case.
you look at this?
Let's look at it. What a weirdo. Let's go with negative point
0,
1 and point 1, and then negative point. Can you see that graph down below?
Oh, my lordy.
All right. So we're not going to use that phrase though. So here we go.
Wow.
Here's what you're going to say.
That's extraordinary.
What ends up happening as you graph this thing is that you will see in this graph that your graph comes down and then does one of these. And you're going to say the limit does not exist, but the word that you're actually going to be talking about is this word.
Looks like my broken slinky.
What does that say? Oscillates.
Like a fan.
Like a fan. So it still does not exist. It's because the graph is oscillating too much. If you were to look in the table to see what's happening, it's bouncing back and forth between positive and negative values. So the three reasons in our class why a limit might not exist is they approach different y values, they approach positive, negative, infinity, or it oscillates.
I won't.
There are three strategies when you're taking limits. Strategy number one, the most important strategy. If you don't do this first, you're a moron. Plug in the number. For example, 4a. Square root of 4 equals 2. That's your answer. Done.
That is hilarious.
Letter B. Does that say I'm approaching 1?
Yeah, third.
Okay, so 1 squared minus 2 times 1 plus 5 is 1 minus 2, which is negative 1 plus 5, which is 4. Done.
Oh, that's not.
Letter C, plug in a 0. 0 plus 1 over 0 squared plus 5 times 0 minus 4 equals negative 1/4. Strategy number 1, plug in the value. And as we continue on, by the way, I've only told you about one strategy really, right, so far?
Plug in the.
We actually have been using another strategy, but I haven't told you about it. What's the other strategy?
Solving calculator.
Calculator. That's the third and ultimate strategy. If you gotta use your calculator, use it.
Plug in.
All right. Letter D. What is the limit of 10 as you approach 0?
10.
That's right. Good job, Joe.
Yeah.
You can't plug anything in, dinglings. What you see is what you get. Just write it down. What's the sign of 0?
1.
I'm going to punch you in the head. Did you just say 1?
No.
It's 0.
0.
Wait.
Cosine
Unit
of
circle
0 is
failure.
Yeah, that's what I thought. I messed up.
Limit. Plug in a 1 and get out.
0.
Seriously. You are so good.
Yeah.
In this very last problem, we talk about something called a piecewise function. We've talked about this before, so I want to remind you. This stuff over here on the right-hand side is called the condition. That's it. Condition. So as I look at what's happening and I graph this thing, this is what my graph looks like. First of all, in the red, I have the number 5. When do I have the number 5? When x is not 2. That means everywhere my graph is going to be at 5, except at 2. So, at 2, I can't be 5, but everywhere else, I'm at the y value of 5. What happens when I'm at 2?
1.
Your y value is 1. So when I'm at 2, here's my y value. Now here's the question. The question is, what is the limit of the function called g of x, that piecewise function, as my x is approaching 2? Remember what I said, put your pencils down and watch. As I'm coming and tracing my graph, the whole graph, from the left-hand side, the y value that I'm getting closer and closer and closer to is
5, 2. Like 1 by 5.
Did I say, what is it? No, I said, what are you getting closer to? The y value.
You're not getting closer to anything. You're just staying the same.
All right, here we go. As I go from the right-hand side of the graph, I'm coming in this way. Oh, here's the first thing I see on the right-hand side. The y value I'm getting closer and closer to is Alexis,
Five.
Joe,
Infinity.
Taylor.
Look, you're staying the same.
Give me an answer.
5.
5, okay. Carly. 5. Abdullahi. 5. Sam.
2.
2. Lucas. 2. All right. Ka. 2. Nate.
2.
2. All right. All the people who say 5, go stand over there.
Can I take my
All the people that say, I don't care, do whatever you want. All the people that say 2, go stand over by the TV. All the people who said infinity, go stand by that back corner.
Me.
All the people who said 1, go stand by the other back corner.
Can I say neutral?
I think I saw a skit about you on the Saturday Night Live show over there. Really? There's nobody has a different answer between those 3 answers? That's it?
Neutral.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
I know, I think.
You guys are the 2s? Right?
Yeah.
So there's none of those. This is the Andrea, the neutral dude over there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, go sit down. This is exactly what I expected. 1 made it in the class, and the rest had some idea what's going on.
Are you good to meet Ted?
Yeah, that was all recorded, by the way.
It was.
All right, now here's the deal. Here's the thing that's really interesting that messes people up all the time. There is a difference between the phrase limit and g of 2. G of 2 says when I plug in x value of 2, what pops out? And the answer is 1. Because limits are y values. So how did you get 2? I have no idea. There's no y value of 2 anywhere on the graph. Anywhere. Because limits are y values. See what I'm saying? There are no y values of 2 anywhere. It's either a y value of 5 or a y value of 1. So if you said 2, I have no clue what you're doing. Because limits are y values. The number 1, which nobody answered in our class, made sense to me. Because there is a y value of 1. Dummy. So that would have made sense, even though it's wrong. Because that's the actual function value. The limit is actually 5. Because it is the number you approach from both directions. It doesn't have to be the function value. It's the number you approach, that's the y value, from both directions. As I look in the red graph, I'm coming in from both directions, and the y value is 5. Only for one instant is it the number 1 for a y value. So the limit is 5.
I get it.
I got 20 on. How do you know?